Hello! Today we continue solving problems on the topic of the motion of a body thrown at an angle to the horizon. And let's begin. A body is thrown with an initial velocity of 12 meters per second. At the top point of its trajectory, its velocity was 6 meters per second. At what angle to the horizon was this body thrown? What is its range of flight and the height of its ascent? Let's write down the conditions of the problem. To begin with, let's put the questions that we will need to work out. Here we will need to find the angle of throwing to begin with, then we need to determine the range of flight and the maximum height of ascent. What do we know? We know that the initial velocity of this body is 12 meters per second, and we also know that at the upper point of the trajectory, its velocity was equal to 6 meters per second. Let's denote it simply as the letter B. And let's see in the figure what this velocity is. In order to show more clearly the relationship between these velocities, let's depict again the trajectory of this body. The initial velocity is directed at an angle of alpha to the horizon and is thrown along the trajectory, which we have found out is a parabola. The upper point of the trajectory is here, and it is characterized by the fact that at this point the velocity, as well as at any point of the trajectory, is directed along the tangent. But here we understand that this tangent passes horizontally, and the velocity at this moment of time is directed horizontally. What is this velocity? This velocity is nothing but the projection of the initial velocity on the x-axis. That is, we remember that this velocity remains unchanged during this motion. That is, at any point of the trajectory, this velocity will be preserved. That is, if I, let's say, plot the velocity vector at this point, I will decompose it into components, and at each point, this velocity will be the same. We denote it by the letter V. Let's keep this notation and show that the velocity at this point is just the projection of the initial velocity on the x-axis. Then in this triangle of velocities, we can write their connection through the angle formed by the initial velocity and the projection of this velocity on the x-axis. Accordingly, we calculate through the cosine of this angle. This is the ratio of the adjacent catheters. This is the velocity along the x-axis, its projection, and the initial velocity is the hypotenuse in this triangle. Thus, at once we get the answer to our question, and let us calculate. The velocity of the upper point of the trajectory is 6 meters per second. The total initial velocity is 12 meters per second. The cosine of this angle is 0.5, which means that the angle of the throw is 60 degrees in this case. So, the first question, we got the answer ourselves. Now, how do we determine the range of flight of this body? To do this, we also have with you the opportunity to calculate according to the known formula. Let's write it down. Here we just need to know the angle of throwing, which we got in the first question. And let's go through the calculation. So the square of the initial velocity, 12 squared times the sine, 2 alpha, that would be 120 degrees. And divide by 9.81 hundredths. That's roughly a range of 12.7 meters. The third question is about the maximum climbing altitude. Let us analyze how this value can be obtained if we consider the movement only along the vertical axis. Here we see you that the initial velocity along the y-axis can also be defined through the angle alpha, and in the process of motion it will decrease, and at the top point, where just we have a body with known velocity, this height takes the maximum value. The component of velocity on the y-axis goes to 0 at this point, so in order to relate the height of ascent, the final velocity at this point in time, the initial velocity and the acceleration with which this motion occurs, we have a well-known formula. Let's write it down. In general terms, it looks like this. And our task now is to adapt it a little bit to this throw. I remind you that we consider the final velocity here exactly along the y-axis. So I will add the icon of projection on this axis everywhere. Here this velocity is 0, the initial velocity is known, and the acceleration with which this body moves is also known, g. And it is directed downwards, i.e. against the chosen direction. So we have to put a minus sign, minus. And here we put that this velocity is zeroed. Then for the maximum height of ascent we get the expression the square of the projection of the initial velocity on the y-axis divided by 2g. Well, and the initial velocity on the y-axis projection we'll write as v by the sign of alpha. We have received the formula by which you can immediately determine the height of lift of this body. And we also do the calculation. Well, 144 is 12 squared by sine squared alpha, that is sine squared 60 degrees, and divide by 2 times 9 whole 81/100ths. Well, and accordingly, after doing the calculations, we get a value for the height of about 5.5 meters. We have obtained the values we need for our answers, and actually we have coped with this task. Analyzing this motion, you and I can connect different points of this trajectory, including through velocities. Pay attention to this method. When you know the velocity at some point of the trajectory, do not forget that you can always decompose it into two components, one of which is preserved throughout the flight. This is the x-axis component. This is a very important point to remember. I'll see you in the next lessons. Goodbye.